All right. So we created a sphere class. It was like a circle. The only difference was, like, it's got a radius attribute, but it also had an x, y, z coordinate. We did diameter, surface area, volume, which, well, diameter was in circle. Circumference was in circle. This is surface area. And volume area, right? Then we did distance between centers, and then distance between edges, which was just the distance between the centers minus the radius. And then, do they overlap? That was if their distance between the edges was negative, then they don't overlap. So now we have magic methods. So underscore, underscore, init, underscore, underscore is another, it's a magic method. But there's other ones we can write. And these magic methods, they're all like, they all have like their special meaning. But the first one we're going to look at is EQ. EQ is equals. This is where we define, this is where we tell Python, what does it mean for two sphere objects to be equal? You get an equals by default. Python will give you, Python adds this method. You won't see it, but Python adds this underscore, underscore, EQ, underscore, underscore method for you. Whether you like it or not, it's there. But the default behavior is that sameness thing, that is. It checks, are these two reference variables referencing the exact same object? That's the default equality. And that's fine. But we can make it more relevant for us. What should it mean? What would be the case that we would say two sphere objects are equivalent? What do you think I should care about? To me, the most obvious idea is if their radius values and their xy coordinates, xyz coordinates are all the same, meaning it's the same size and it's in the same spot in space, they're equal. Does that seem reasonable to you? So here, I guess I got to go add all this code. Let's start. And then we'll go down here, and let's create two spheres. A equals so when I run this, it's using the default equals. Are they literally the same thing? I change this to C. No, that's because it should be A. There. The default behavior is, are they literally the same thing? But, you know, does A equal B? I want this to be true because they are the same size and they're in the same spot in space. They both have radius 1 and they are both at the origin. So if that's the case, they should be equal. All right. So we tell Python what it means to be equal by saying def now the name other doesn't really matter. It's a good name, self, other. And we will return, well, does self radius equal other radius? And there. Now, maybe right now, self and other, maybe self will make a little bit more sense to you. Self is the instance, is one of the two instances in this case, and other is the other one. So I want to say, when I'm asking a sphere, like, hey, are you equal to another sphere? I say, hey, self. The sphere asks, hey, what's my radius and what's the other one's radius? Are they the same? X, Y, and Z. So now when I run this, I update the EQ, and now, well, it's true. A and B are equal. If I were to change one of these attributes, they shouldn't be equal anymore. Great, we've defined equality. Now, you'll notice I'm not directly calling this method. I can. I can call it directly. I can. But don't. If you are ever calling a magic method with underscores directly, you're doing something wrong. You're not really supposed to. So when I look at it like this, and I say, hey, A underscore underscore EQ underscore underscore B, in this context, it goes and it runs the method starting by what's defined on line 17 of the previous cell. In this particular example, I have A and B. Those are two reference variables to two different spheres. In the method, I have self and other. Which one is self? There's two spheres. Which one is self? The first, the A, the one the method is called on. Therefore, which one's other? B. If I were to change this to B and A, the order doesn't matter, but of course the functionality does technically change a little. Well, the functionality doesn't change, it's just which object is actually being asked is changed. But here, B would be self and A would be other. But like I was saying, we never call this exactly or directly. We call it indirectly with something like this. So when I say, hey, A equals B, it calls the equality method. The magic method, the underscore underscore EQ underscore underscore, that is called automatically when you say equals equals. So never write this. Always write this if you want to check equality. Any questions about that one? Yeah.
So if the underscore equals or EQ is called by the double equal sign, then are there other magic methods that are called by other operators?
Yep. Like, you can define what it means for one sphere to be less than another sphere. You can define what it means for them, what happens when you convert it to an integer, to a string. What happens if you, there's a lot. They're not just operators, some of them are like functions, kind of like what happens if you try to convert it to an int. You know how you say int, right? But all these magic methods pop up in different contexts. There's a lot of them. And most of them you're only ever going to implement in special cases. But EQ is one you always want to define. It's always important to define what it means for two objects to be equal. It's important. So there's a lot of magic methods. You can go look them up, Python magic methods. You'll find a giant list of them. But the ones you really want to implement are, well, you need your initializer, the constructor. That's just, you're typically going to have that. You've got your EQ. You're going to want to write that one. And the other one you're going to want to write is repr, which I'm going to talk about in a moment. Now, I will say, if you're thinking to yourself, how would I have known to define the equality to be if all their attributes are the same? And my answer is, you're not. It's up to you. If you're inventing this class, it's up to you to decide what it means for two spheres to be equal. If for your purposes, you thought to yourself, I don't care where they are in space, If they have the same radius, they're equal. That's what I care about for my code. Great, awesome, do that. We can do that. Whoop. There. Let's redefine it. Now, it's not going to matter where they are. All that matters is that they have the same radius. And if for your needs that's what you want, do it. If at any point when talking about this class stuff, you're thinking, how was I supposed to know how to do? Most of the time the answer is you're not supposed to know. You're inventing. It's up to you. It's not what you ought to do. It's what makes sense in your situation. That's a decision you need to make. If you think, I just care if their radius or their x's are the same, I don't care where they are, or y or z planes, fine, whatever. That's kind of weird, but do what you want. Put that back, though. Cool. Any other questions about EQ? All right. The other one that we get, that we often like to write, is repr. Like EQ, we get a repr for free. But that's what it does by default. It says main underscore underscore main underscore underscore dot sphere object dot ox78484c844a whatever. Print B, there. Another one. We're printing out the other one. Great. This is the default behavior. Whether you write a repr, it doesn't matter. You get one, and this is what you get. But that's not, a lot of times, that's not all that helpful. A lot of times, I mean, maybe it is helpful in your case, fine. But just seeing the name of the class and its memory address isn't telling me a lot. Because usually, if I have an object, and I'm like, tell me about this, like, I want to print it out so I can see quick and dirty when I'm debugging, right? How many times have you been writing code and you just print out something to see real quick? Have you ever been writing code and then you just print out a whole list at once and you see the list just to help you understand what's going on with the values? Yeah. Someone wrote a repr for a list class. And the repr for the list class says, start with a square bracket, put all the contents in there separated by commas, and then when you're done, close with the square bracket. Someone wrote that code. That's the repr. The default repr for the list before someone wrote the repr would have been something that looks exactly like this, except it would have said list object at blah, 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 blah. But they wrote a repr that makes sense for what that class is. It's a collection. Here, this is what we call a plain old, this is a simple class, a very, very simple class. It stores some attributes and has some basic functionality, fine. And whenever you have a class like this, there is a bit of a convention people follow for writing their reprs. It's name of the class, open parenthesis, and then each of the attributes, close parenthesis. Kind of like this. It would basically look like that. And I'm lazy, so I'm just going to go and copy the repr. Oh, oops. Before we go to repr, give me a moment here. I want to take a moment and talk about, why is that line emphasized? Talk about something here real quick. Actually, no, I'm going to come back to this after we talk about repr. So we are going to overwrite the repr. Now, a lot of students mess up. Repr does not print anything. It doesn't print. It returns a string. Very different. If your repr prints something, it's not going to work right. Your code's going to be busted. So here, I write the repr. And what it says is say sphere, open bracket, and then sometimes if you want, you kind of like label each of the attributes. The x attribute is self.x. The y attribute is whatever self.y is, z is whatever z is, and radius is whatever the radius is, and then close parenthesis. When I hit run, and now I'm going to run this, suddenly we see, well, A is a sphere with x of 0, y of 0, z of 0, and radius of 1. Now, it didn't need to be like this, but this is a common pattern people follow when you have a simple class that's just like this. Just name of the class, parentheses, attributes. That's commonly what you see. But now, if you're writing code and you've got some sphere objects and you say, what's that one's like attributes again? I want to see what they are just for, make sure they are what I expect them to be. Well, now you just print out A and you can see them right there, easy peasy. If you were to print it out before, sphere at OX78B214F, whatever, that's nonsense. Now, suddenly, you've got a much better repr. When you have a function, or pardon me, a method that you get for free, like EQ and repr, when you implement your own version of them, like here we now wrote repr, it eliminates the old version. In fact, what we say is we are overriding the one you get by default for free. We override the default equality to say, no, don't use that one, use this one. We override the default repr. Don't use that one, use this one. So yeah, this is an example of overriding the repr and the EQ. Any questions about this repr? Now, to make sure it's clear, if you're like, should I have known to be like that? Well, in this particular case, this is the convention. But really, like, look, here, whenever I try to call repr, it's going to return blah, 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 blah. Not very helpful, but to give you a sense of, like, it's just going to return whatever this string is. Now, do note that really, so again, I'm not going to call it like that. I can, don't. Never call these magic methods directly. But in reality, it's not the fact that I printed out A that called repr directly. This is actually even more indirect. Really what's calling it, and there's some nuance here that is not going to matter for our purposes, but really, if I were to say C equals str of A, and then print out C, now, well here, let me go back to what it was. Oops. It's when you convert it to a string, that's what's calling the repr. The representation of it, right? Now, there's actually some nuance here, but we're not going to worry about it. Whenever you print something out, Python will automatically convert whatever you're printing out to a string. So, really what happened is print called stir, which called repr. Not that important, but just as an FYI. So, any questions about the repr? Yes? Let's see. So if I delete it and I rerun it, and I run it here, yes, it does. But now you got to be careful here to make generalizations about what's going on. If I write a function, this is because every time I run this, I am redefining this whole class, and everything in the class gets updated. But if I go down here, let me show you really quick. And I just have some function, ASD, right? And I go down here and I say, okay, ASD, right? And then I go, no, I don't want that anymore. And I run it. I got rid of it. Well, no, I didn't. It still exists. If you really want to get rid of it, you have to restart your runtime. Restart runtime. The only reason getting rid of it here worked was because it redefined the whole class. You're basically, when doing this, it's saying, it's kind of like I'm redefining what ASD is to be like more like this would be, I suppose, more similar. And now, like, it still exists, but it doesn't do anything. So the sphere still exists, but something like, it was because it was within the sphere class. The sphere class is what changed. So it's kind of funky, but the quick answer is, yeah, it disappeared, but be careful. Other questions? So now, we've got a bit of a problem with our EQ. Okay. So A and B are obviously not equivalent, right? They're two different spheres. If I go change it, okay, now they are equivalent. Are A and C, are A and C equal? This isn't a trick question. No, it's in fact, it's kind of a stupid question, right? Is that sphere equal to that list? No. I can even be, oh, okay, maybe, I mean, I could make it look like it's, but it's obviously they're not the same. One's a sphere and one's a list. They're not the same. So when I ask, hey, does A equal C, I want to get back false because they're not equal. But when I run it, it crashes. Because it says other has no attribute, radius, x, y, z. You go look at the code. When I run this, C is other. And when I say, hey, other.radius, this class, this EQ is expecting other to be a sphere because spheres have radius, x, y, z coordinates. Those attributes exist, so I can access them. But when other is a list and I say, hey, list, tell me your radius, the list is going, what? I don't have a radius. I don't have an x. I don't have a y. So the program crashed. But we don't want our program to crash here. That's not helpful at all. We want it to say, no, they're not the same. So a really easy solution to this is to start by saying, okay, if is instance other there. We fixed it. If other is a sphere, that's what that line 18 is now saying. Is instance is a function that will tell you if other's type is sphere, if it's an instance of a sphere. If other is a sphere, then go do the check. If other's not a sphere, they're not equal. It's as simple as that. No need to check their attributes. If I say, hey, are you equivalent to that chair? No. We don't need to look any further. We could just say, no, they're not the same. So with this updated version, it now shouldn't crash. It'll now say, well, no, they're not the same. Because other was not a sphere, therefore this code didn't run. If it makes you happy, we could do this, else. There. If it's this, return that, otherwise return that. Well, it's not a sphere, so we go down to the else, return false. Now just to take a moment, if you stumbled on this, just remember, slow down. Whenever a function or method sees a return, it immediately stops executing. So even though we see the if statement, and with an if statement, the pattern is, if it's true, run everything in the if statement, and then carry on and run everything afterwards. If it's not true, you skip it and just carry on afterwards. So if you're thinking, well, why is this not returning like true and false? Well, as soon as a return is hit, it stops. So we didn't really need the else because if this was ever true, it would immediately stop running on this line, and it's not possible to ever get here. This is a common pattern, but if you don't like it because you're like, this is more explicit. Even though it's functionally equivalent, this is more explicit code, and I like that. Good on you. Awesome. Good job. If you think that's better, do it. If you think this code is more self-explanatory, clearer, that's a good thing. I say it a lot. Remember, code is not for computers. No. Machine code is. Zeros and ones is for computers. Python code is for humans. So make it as human readable as you can. So if you think this is more human friendly, do it. What do you think if this was the circle class, what would you make the circle class's EQ? Should be a simple answer. What attributes did the circle have? Do you remember? I'm hearing a lot of...
Radius.
Yes. So what would be a reasonable equivalent equals method for a circle class? Check if they have the same radius. Makes perfect sense. So basically, it would be this. Right? But of course, it would be in the circle class, and we would want to check if they're circles instead. Remember, the context, I don't have the circle class written here yet. I just didn't have it here. We saw it before, and I didn't have it written here. But if I were to add that EQ method to the circle class, we just talked about what it would look like. And then our code would have two EQ methods, one inside the sphere class and one inside the circle class. But they're both EQ methods. But imagine for a moment, right? I know the circle doesn't exist, that's why it's underlining. If I said C equals A, think carefully for a moment, because there is an easy, obvious answer, but, just rationalize about it. Remember, the method that's called calls that method from within its respective class. So if I say C equals A, remember, I have two equals methods, underscore, underscore, EQ, underscore, underscore. One in the sphere class, one in the circle class. When you look at this code and I say C equals A, which one of the two got run? Only one of them got run. Why? Because, this is, even though we don't ever call it like this, imagine we did. This might make it clearer. When I say C dot equal, what type is C? If you're being quiet because you don't understand, I'm really concerned. If you're being quiet because you're apathetic, I'm annoyed. What type does C have? Oh, okay, good. So, what EQ method got called? The one in the circle class or the one in the sphere class? Circle. Because I asked a circle, hey, are you equal to this thing? And it goes, well, let me check. If I were to change this, which one is it going to run now? A's. Well, what type is A? So it goes and it checks the spheres class's equals method. So even though we have two methods with the same name, the context matters. What was the type of the object that you asked? That's what matters. They are entirely separate. Even though they have the same name, they're independent from one another. Any questions about that? Now, if I were to start writing a cert test for this, oof, it's getting pretty hairy, right? Look at that. First, I have to create a sphere class, and then check, okay, what's its x, what's its y, what's its z, what's its radius, diameter, surface area, volume, distances. It's getting to the point where, like, look, each of these is not really obvious anymore. There's a wall of tests. Am I being thorough? I don't know. I'm really only testing two different type, like two instances of spheres. I don't know. It's kind of weird, but these tests are getting kind of hard to manage. Okay, any questions about classes, objects, circles, spheres before I carry on to the next topic? Because now is the time to ask. All right. So we saw in the previous example, so we started with a circle. And we just made a circle class. I showed you there's like attributes. We could have functions, but we call them methods because they're called on instances of objects. And we can create instances, and then we can call the methods on those instances. Great. The sphere, we did the same thing, but we added a little bit to it. I showed you how you can actually have two sphere objects kind of like interacting with one another. I asked one sphere, hey, how far away are you from another sphere? Which was kind of neat. So we had two objects of the same type interacting, but we don't stop there. We can now have different types. And we can have different, like objects have other objects that interact with other objects and other objects and whatever. We can do this all day long. And that's what we're going to do here. We're going to keep it simple. So, the sphere needed to know its location in space. And because of it, we stored three attributes, x, y, z. But you know, pause for a second. I want to be very clear that the changes, I'm going to modify the sphere class. This modification is not to show you that, oh, this is the more correct way to make the sphere class. No, it's not more correct. I'm just modifying it in a way that makes sense, but it doesn't mean it's better, but it does, this is another design decision. Because the x, y, z coordinates of my sphere class are, you know, those are three different attributes, but really those three attributes are kind of like one thing. It represents one piece of information, really. Even though there's three, it tells me its point in three-dimensional space for this sphere. And in reality, if I'm writing code that has like three-dimensional objects in space in it, spheres that are defined by a center point and a radius, presumably I might want to also define like a cube class. That is also going to need like x, y, z coordinates. But a cube is going to need like 6 of those. 1, 2, 3, 4, 5, 8. Ugh. Yeah. 8 points to define like the cube. I guess not really, because some would have to be certain values, but like if we were creating some 6-sided point in three-dimensional space, we would definitely need 8 points to define it. So there's going to be a lot of like redundancy there. So how about this? Let's extract that x, y, z, those attributes. Let's get rid of those attributes from the sphere class, and instead make another class called a point 3D class. That's going to basically be the x, y, z coordinates and provide the functionality for the point-related stuff. So before, if I wanted to know if two spheres how far apart the center points of two spheres were, I asked the spheres. But really, that functionality, that question, should really belong to the point. The points should know how far apart they are. A sphere has a center point, and then the sphere can ask the center point, how far away are you from some other point? As opposed to asking the spheres. So we can delegate that work to another object. The sphere will still know its surface, it'll have its functionality to calculate its diameter, its surface area, its volume. And we can still ask the sphere, how far away are you from the center point? Like, how far away is your center point from another sphere's center point? But when we ask a sphere to do that, the sphere is just going to delegate that work to the point class, which we will see. So, X, Y, Z. Let's start. There. Now, great. We've got a point 3D object we've created already. It's got its X, Y, Z as attributes. That's really it. We've defined it. Great. And already we can make point 3D. I can already make instances of this object, and they already have their attributes. Cool. And the functionality I want to add is going to be, well, how far away is one point from another point? So basically the same thing from the sphere. And I also want to define equality and repr for a point 3D as well, because we always really want to define these magic methods. So distance from other point. Oops. There we go. We get rid of all the doc strings for brevity. Cool. So now points can calculate how far away they are from some other point in this three-dimensional space. And then equality. What would you think is a reasonable equality check for points? I don't know about you, but I think just if they existed the same point in space. So first we check, is other even the point 3D? And if it is, then go ahead and do the comparison. If self x and other x are the same, self y, other y are the same, and self z and other z are the same, they're the same point. And finally, the last thing we're going to want to add is the repr. Which is the name of the class, point 3D, followed by its just attributes, x, y, and z. So now with all this written, I can just print out a point, and that's what we see, which is awesome. Cool. So now the trick is, with this defined, I can go back to the sphere class, replace those three x, y, z coordinate attributes with a single attribute, point 3D, called like center point or something, and go and update the distance calculation method to just return, just to delegate the work to this point 3D class. And because we really don't have time to do that, I don't think, well, let's see. Okay, here'd be some tests for point 3D. So here's how, I'd be rushing. I don't want to rush through this part. So I'll stop lecturing. This is what we'll pick up next time on Monday. Are there any questions before we wrap up today? All right, I'll see y'all later.